Welcome back, friends. In this section, we'll look at machine learning fundamentals. In the previous section, you should have completed an assignment, and if you ran into any difficulties or problems with that assignment, go ahead and take a look at the solution file found in the code bundle. In the first video, we'll focus on basic statistics. Specifically, there are two items that we will look at. The first one is correlation, and if any of you had statistics before, you know that it's a measure of how strong a relationship is. Typically, it would be looked at among variables, but in this case here in Spark, we're looking at it in terms of a series. And in Spark code, correlation computes the correlation matrix for the input dataset of vectors. And be aware that the output will be a data frame that contains the correlation matrix of the column of vectors. The second item of basic statistics that we'll look at is hypothesis testing, specifically the chi-square test. This is a measure of goodness of fit between the observed values and the expected values. And in Spark code, the chi-square test does the Pearson's independence test for every feature against the label. For each feature, when you have the feature label pairs, those are converted into a contingency matrix for which the chi-squared statistic is computed. And all label and feature values must be categorical values. So let's head over to the Jupyter Notebook and take a look at some code. So we'll begin as usual as importing Spark context and importing the Spark session builder. And the first part we'll look at is correlation. So we need to do some imports. We're going to import vectors from PySpark ML linear algebra. And then we're also going to import correlation from the PySpark ML statistics. First, we want to create a list of sparse and dense vectors. And dense vectors, as the name suggests, is that there are a lot of values present that are non-zero. Okay, so you see the 4, 5, and 3. And so this array presented in a list is basically the values arranged in this vector format. Now for sparse, it's a little bit more complex. For sparse vectors, this 4 here in that first position means that there's going to be 4 slots. This is going to be an array that has 4 items in it. And then within this, there's this list here with 2 tuples. So this first tuple where you see the 0 and 1, this tells you that index position 0, the value 3 is stored. At index position 1, the value of -2 is stored. And again, the array size is 4. So this is a more succinct way of communicating what the values are in a sparse vector. So let's take a look at the object. And now we want to create the data frame, and we're going to input the data and then the features here. So let me show you what that looks like. Okay, so we have the features column, and then we have the data presented below. Now, correlation computes the correlation matrix for the input dataset of vectors. So here we have correlation.core, and then we're going to input the data frame. And let me show you what this looks like. It's a correlation matrix. Ones are across the diagonal. Where computation was impossible, you get back NaN, not a number. And then everywhere else where computation is possible, you get the actual correlation values here. Now let's do the same for the Spearman correlation. Again, you have to use correlation.core. And then here we show ones across the diagonal, then we get back some nada numbers, and then we do get back some correlation values here. So this ends the section on correlation, and we're going to move on to hypothesis testing. So we need to do some imports. We're going to import vectors in the chi-square test. And then we start off with dense vectors. We've got the situation where we've got labels of zeros and ones, and then we have feature data, which are the dense vectors. Now we need to create the data frame, and then let's take a look and see what this object looks like. It shows that we have a row object, and it presents the information with the p-values, degrees of freedom, and the statistics. And I've rearranged it differently, printing them out in this format so you can take a look at this area. Let's stop the Spark session. In this video, we've taken a look at some basic statistics.